So we're going to solve for x on this. And we see two triangles. This, whatever the shape is, some kind of quadrilateral. It's been cut right here from corner to corner, making these two triangles, which is very convenient because we have a right angle here and a right angle there. Since we're seeing right angles, we should be expecting to use the Pythagorean theorem. And since we love to do it, that hopefully, it's not too bad. So first off, I got this leg and this leg right here. Sorry, my lines aren't very straight, but we know these are legs because they make up the right angle right there in that first triangle, and then we have this hypotenuse right here. So the two values that they gave us were a leg, which I'm going to just make the first leg once again. I might do a better 6 than that. Wasn't very much better, but the hypotenuse is 9. So we have a leg of 6, a hypotenuse that is 9. So we're going to take 6 to the power of 2, and we're going to add the leg squared there, and that should equal 9, the hypotenuse squared as well. So just old-fashioned evaluation here, so we can use the calculator. 6 to the power of 2 is 36, and 9 to the power of 2 is 81. 9 times 9. So now we have this new equation. 36 plus the leg squared equals 81. And we're pretty close to getting this leg, at least leg squared even. But we're going to use the principle of equality now to solve for the leg squared, which is hopefully going to help us to solve for the leg. So I don't want that 36 with it, so I'm going to have to zero that out by subtracting 36. All right, so this is what happens. The 36 zeroes out. That's part of the plan. We've zeroed out the leg squared. 81 minus 36, when I did this in the calculator, gave me 45. Now that's a leg squared. If we wanted just the leg, which may or may not be helpful, but I'd have a leg. If I wanted it, I would have to square root both sides there, like this. And the square root of 45, we're just going to keep it as the square root of 45. If you'd like to see the simplified square root there, you can. For example, again, we'll look at the two factors of 45, such as 9 and 5. I'm using 9 specifically because it's the largest perfect square factor of 45. And then if we were to square root those, the square root of 9 is 3, and then the square root of 5 just is the square root of 5. So either the square root of 45 or 3 times the square root of 5. I'm going to keep the square root of 45 right here just because I'm going to need it. I'm going to need that. Plus, it's easier to type than 3 times the square root of 5. So we just found then this length, this thing, I'll do it in orange there, this other leg right here, as the square root of 45. Which means now that we can look just at this triangle right here, right? We've already figured out this triangle. If we want to ignore it, then we can. In fact, I'll redraw that triangle just to make this hopefully a little bit easier to see. So right now we got something that looks like this. And we're all going to pretend like my drawings are good. So yes, it did give us the right angle there. We got this right angle, which means I'm looking at this leg right here that's 5. The other leg is an x, but we have a hypotenuse that's the square root of 45, which used to be the leg of the first triangle. And again, if you want 3 times the square root of 5, that's fine too. So we'll solve for this one pretty much the same way as that last one because we are solving for a leg once again. So we're going to go back to the Pythagorean theorem. And we love it so much that it's good to see it again. There it is. All right. So I'm going to take this Pythagorean theorem. I have one of the legs of this new triangle, which is 5. A hypotenuse, which I have in orange as the square root of 45. And again, this is why keeping this in a square root format like this without having to simplify it back here is good because we're going to square that square root, which is going to undo it. So now we've got 5 to the power of 2 plus the leg squared, the other leg squared, is going to equal that square root of 45. And you can just put the power of 2. If you want to put it in parentheses, that's fine too. But the calculator is going to find it either way, even though I'm not going to use a calculator for it. So 5 to the power of 2, 5 times 5 is 25. This is going to be added to the leg squared, which will equal the square root of 45 to the power of 2. Again, it's just going to be 45 right there. Okay, because the exponent will undo the square root. That's it. So now we have this equation to solve. And we're going to use some principles of equality, because what I'd like right now is take that leg squared and get it by itself, meaning I don't want the 25 there. I'm going to have to zero it out by subtracting 25. So leg squared then, because we did zero that out and dropped the leg squared. 45 minus 25 is 20. So 20 is not a perfect square. And I'm saying that because the next step is to take that leg squared and just make it a regular leg. And that will be the value of x. And which, by the way, if you wanted to make that an x, you could have. But in order to make this leg squared a leg, I'm going to take it and square root it. So I'm going to square root 20. So I'm going to show it as the square root of 20. Again, as a decimal, it was pretty ugly. The square root of 20, enter 4.472135955. We don't want that ugly decimal. What we want is the, I guess they didn't say, round to the nearest tenth. Oh, I guess we do. Okay, well, fair enough. The leg then, according to my calculator, is showing is 4.472135955. So that's the ugly decimal. What we want is the rounded decimal. 2 at the top, it says to the nearest tenth. So the tenth is where the 4 is. To the right is a 7. Since it's 5 or more, we're going to have to add 1 to the 4, making this leg in the end 4.5. And I don't see any labels there. That's okay. So just to see, if you want to do this by hand, which not many people do, but since I do, I'm going to show it. So the square root of 20, if I were to look at the factors of the square root of 20, the biggest factor of 20 that's a perfect square is 4. So that'd be 4 times 5. I would take the square root of both of these. The square root of 4 is 2, and then we just got that multiplied by the square root of 5. We wouldn't make this any simpler, because we can't, because the 5 is not a perfect square, and it doesn't have any factors that are perfect squares. So this value, or the square root of 20, would simplify here if we needed the answer in radical form. Radical just means it's got the square root, but we did it over here with the rounding, and that's pretty good.